Let us discuss the analysis of RC circuits just after closing the circuit. We have discussed two situations for a given RC circuit. One is charging of a capacitor and the other is discharging of a capacitor. If we just talk about charging of a capacitor, the situation is like this, in which a capacitor in series connected with a resistance along with the battery of EMF V. Now if we close the circuit at t equal to 0, we know the charge on capacitor is supplied by the current through the battery, where the charge on capacitor is written as CV1 minus e to power minus t by RC, and the charging current we can write as V by R e to power minus t by RC. Now in this situation, if we just have a look carefully, then at t equals to 0 plus, just after closing the circuit, if we just analyze, you can see charge on capacitor was 0, but the current in circuit is V by R. So here V by R current will flow only when this capacitor behaves as a short circuit wire or just like a straight wire. So we can say at t equal to 0 plus, that is just after closing the circuit, all uncharged capacitor of circuit behaves as a straight wire or short circuit. And if we talk at t equals to infinite or after a long time in a steady state, we know the value of current is 0. That means after a long time a capacitor behave as if it is an open circuit. So we can write at t equals to 0 plus, if we have an uncharged capacitor in circuit, it behaves as if it is acting as a straight wire. If the capacitor is connected across terminals A and B appear like the short circuited terminals if the capacitor is uncharged. Similarly, at t tending to infinity or in a steady state, we can say that if we have a capacitor connected across two terminals, then this will act as if this capacitor is acting like an open circuit. There is never a current which is allowed to pass through the capacitor in a steady state. This is the situation you should always keep in mind. Similarly, if we talk about discharging of a capacitor, in that situation we have studied if capacitor is charged with a charge plus Q and minus Q, and it is connected across a resistance, and if the switch is closed, it is discharged with the current I with the charge plus Q minus Q on the plates, such that the value of charge on capacitor is given as Q e to power minus t by RC, and the discharging current is Q by RC e to power minus t by RC. In this situation again, if we talk at t equals to 0 plus, that is just after closing the switch, you can see we also discussed about it that current value in the circuit is given by Q by C upon R. That means the capacitor behaves just like an EMF Q by C, due to which Q by C upon R current flows through it. And at t equals to infinity or after a long time, if we are talking, we can see the value of current will be 0. That means in this situation at t equals to 0 plus, if we are given with a capacitor in a circuit which is initially charged with a charge plus Q and minus Q, then it will behave as if instead of a capacitor there is an EMF connected of value Q by C across the terminals A and B. This is just after closing the circuit in which an already charged capacitor is connected. And here after a long time in a steady state, this capacitor also behaves as if in final situation it is acting like an open circuit, like if it was uncharged. No matter what a charge is there in the final situation on capacitor, but final current in the circuit is 0, so we can say it behaves as if it is acting as an open circuit. And if the capacitor is initially uncharged, then also in a steady state it behaves in the similar manner. The only difference in the two cases, whether it is charged or uncharged, is just after closing the circuit. An uncharged capacitor behaves like a straight wire or short circuit, and a charged capacitor behaves like an EMF just after closing the circuit.